So we have Dr. Bhanuprakash Reddy, who will cover up the importance of trace metals and vitamins in renal nutrition.
Thank you, sir. Quickly, I thank the organizers, particularly Dr. Manisha Sahai and Dr. Swarnalata, of course, my current collaborator, Dr. Manju Shah. I have quite a few disclaimers, but quickly, couple of them. Number one, I am not a medical doctor. Neither I am a nutritionist or dietitian. The least, I am not even a renal biologist. But why I am here is, we did a small work with Dr. Manisha Sahai. She wanted me to share some of that data with you. Well, that piece of work that I am going to share with you probably has least implications for your day-to-day clinical practice. But just as a research experience, I am going to show it to you. But this data, what I am going to show is a part of the bigger picture that we have been working over the years on a set of diabetic complications. But for today's talk, it is on diabetic nephropathy. So the idea here, taking up this the bigger umbrella, studies under this umbrella, is to I can do it. Even in 10 minutes, I can close it. That's not a problem. So that altered nutritional status is linked to development of diabetic complications, and most importantly, in our context, we keep on talking micronutrient deficiencies. So micronutrient deficiencies may or likely to predispose some of the diabetics to diabetic complications. So in this context, we have been working on a set of diabetic complications like retinopathy, neuropathy, nephropathy. But I would not bother you with all other things. The reason I am showing is that the genesis is from here. So while I was working with retinopathy, I happened to meet both the Sahais, and we started doing something on nephropathy. Okay, this is a busy slide. Don't worry about it. But what I am going to show is that all the 3 or 4 complications we have matched for many other things. These are all clinical parameters. But one important thing is the duration of diabetes is matched for all these complications along with the no complication diabetic group. So this is the slide that initiated for me to get into the work that I am going to share with you in the next few slides. Is that you see in diabetic retinopathy we found some micronutrients, particularly B12 was significantly low. But whereas in diabetic neuropathy, the last column, we found that B2 and B6 was low. But what was a little bit perplexing to me, because I am not a clinician or neither a practitioner, that in nephropathy, the red column, all these nutrients in a circulatory level are high. At that point of time, I did not know what to do, how to interpret, what to explain about it. Of course, these are simply in blood levels. So then I had a chance to sit with both the Sahais, discuss extensively, and then they said, why don't we do it in a different way? So then, as they suggested, we did a systematic study to explain these increased levels of vitamins and micronutrients in diabetic nephropathy, particularly in the blood plasma. So we took again same control, diabetes without any complications, diabetic nephropathy, that is DKD, and non-diabetic CKD also. That is what they suggested. Why don't we have a group which is not a diabetic but CKD? Well, this is a very properly planned study. I would not bother you with all the details, okay? And all the information is collected. And of course, this is where I am quite okay to say anything about it, because this is what I do day in and out in the lab. Well, now coming to the point of these minerals today, all the vitamins we found in the circulatory level very high. Some of them are significantly high. So we wanted to see what happens to the mineral status. And at that time, I was not very equipped to do all these things, but we put in a lot of efforts. And then this was, though we do minerals in food samples, but in blood samples, we really had to struggle a lot. And then finally, we managed to do it by advanced technology, that is high resolution ICP-MS, inductive coupled mass spectrometry. So here again, I don't expect you to worry about all these numbers in the table, but what I want to say is that you can see that plasma creatinine, as expected in both non-diabetic and diabetic CKD, is high, and of course you also see USCR and EGFR as expected. It is not surprising, just I wanted to show you this. Now the next thing is that we started first showing the value. I am only showing some vitamins again coming back to this study that B2 you see with the disease stages, that is control, no complications and diabetic kidney disease and CKD, which is not a diabetic group. So, in both whether it is diabetes or no diabetes, in CKD the B2 level is high. I have data for all, but I just quickly I want to show it to only one or two, then I will come back to the minerals. Similarly, when you go by microl category, you can see that in a overt microl or microl, the B2 level is high in a circulatory system. So, also by EGFR status. More or less similar situation was found with B12, and as I said, I am not going to show all other things. But here quickly we are trying to understand why these vitamins levels are high in circulation. There could be many other things, but probably impaired intestinal absorption could be one reason. At this point of time, it is only assumption, but one needs to validate. But that is very much possible, and also impaired filtration and uremia. Now, this was a part of PhD program of a graduate student, and he tried to look into the available information, if anything already is there, how to explain this. And he found that some of these vitamins were increased in dogs with CKD compared to healthy dogs, and this decreased renal clearance in the CKD may have led to the elevated blood vitamin levels. That's what is the explanation. And of course, uremia is known to affect the specific enteric vitamin carriers. That may be the reasons for the higher levels in the circulation, and potentially impaired release of stored vitamins. Sometimes that happens. So, all in all, what the existing literature also says that higher levels of particular B vitamins encountered in some cases. Okay. So, but coming back to as a biochemist, we were also trying to understand, because I was doing some biochemical aspects in diabetic complications as I started in the beginning. So, there is a functional deficiency actually, even though you have higher levels in the circulation. Why would I say functional deficiency of B6, B9 and B12? Because we found higher homocysteine. And homocysteine is regulated by many other factors, including these three important B vitamins. So, that is number one. Number two, megalin mediates uptake of transcobalamin complex into the proximal tubules. Megalin is involved in the uptake of and degradation of some of the modified proteins, which we call it as AGEs. And in aging, diabetes or renal dysfunction, AGEs might overload megalin. Therefore, megalin is not able to basically it has a megalin thus lowering the cobalamin uptake. So, that could be one of the reasons. Therefore, diabetes and renal patients show high concentration of cobalamin in a circulation. So, plasma levels of B vitamins, this is my interpretation at this point of time, but you all can correct me, and we have not published this data. So, this may not represent cellular levels and functional deficiency, because I take one point, that is homocysteine, but there could be many other reasons. So, why would I say that? Again here, as I said, we have been studying the protein modified proteins in different diabetic complications, including diabetic nephropathy. You could clearly see that AG levels are higher as your USCR is high, and AG levels are high when your EGFR is low. That means in a renal failure, your modified proteins are very high. That is what I was saying, that these modified proteins overload megalin. That may be the reason for finding these results what I showed it to you. So, well, I am done, sir. In the next 2 slides, I will finish it. Coming back to minerals, we thought, how is it going to show with respect to minerals? They are vitamins because some of them are required transporters, there are many other physiological changes. Dr. Dole also mentioned with respect to sodium and other things. So, we wanted to see how it happens. But, unlike vitamins, in case of minerals, whether it is calcium, I am showing here for calcium, vanadium, chromium, all of them with a disease status, the level is low. So, also iron, cobalamin and copper. So, more or less all except selenium, all minerals are decreased in the blood, that is particularly in the plasma, with respect to either disease status or even microl status or EGFR status. So, what is the point here? In a limited summary, this is compared to the control group, plasma levels of majority of the minerals, particularly calcium in this case. I see calcium is very distinctly low, others are somewhat in a kind of trend. So, majority of the minerals were lower in the diabetic and non-diabetic kidney disease groups. So, this part of the work is published, and wherein we have also showed dietary intake of all these vitamins and minerals, but for want of time I am not showing. But just in a larger picture, because I said the summary was a limited point, but in the larger picture, as I said, we found inadequate dietary intake of the vitamins and minerals which I showed in the plasma, and of course, which is actually again reflected in the mean probability of adequacy, which is only 20%. And there are altered biochemical pathways. I have not shown all except the modified proteins. And these modified proteins are likely to influence these circulatory levels. And there is also a functional deficiency with the help of homocysteine. And that may be the reason for elevated circulatory vitamins. But at the same time, there is a lower plasma levels of minerals, which at this point of time, I do not have too much of explanations, but we are trying to still continue this work with a larger number. That's why I requested Dr. Manjushar to replicate this in some other center. We did this at Usmania Medical College. Now I want to reproduce and replicate this in some other center and with a larger number and see what picture emerges. So all in all, one limited point, probably these circulatory levels do not represent cellular levels, but we need to validate that. So the reason I repeatedly say this point is that when you take individual vitamins or some of these nutrients, people keep saying that vitamin D is decreased in renal dysfunction or diabetic nephropathy. I see many of the papers like that, but I don't know whether they have put this into the bigger picture. Did they explain about it? How did they arrive it? What is the methodology? I just want to make a point to all of you that whenever somebody publishes a nutrient in a renal dysfunction, whether it's a diabetic nephropathy or CKD, I want to see whether that really stands valid. That's all my request to you all. Thank you. Thanks a lot.
Thank you, Dr. Bhanuprakash Reddy, for your sacrifice in cutting down your talk and helping the organizers.
Well,
so all my speakers actually have done a phenomenal job. We got the mic at 9:30. We are leaving the mic at 10:30, which is 1 hour symposium. Thank you so much. I think a lot of has been learned, but 3 things will not go out of fashion. One is salt restriction. Guidelines have come and gone, but salt restriction is everywhere. Number 2, home cooked food versus packaged food, which again will continue to remain in fashion. And number 3, to be friendly with renal dietitians. Have many more of renal dietitians in your clinic. I'm not suggesting SRNM Con to start a matrimonial service, but in general, I think it's very fair to have a dietitian in your clinic. Thank you so much for the patient here.